For example number 1, we're asked to find the derivative of the following. Okay, so they give us a function. They say, okay, g of x, some function, and it's given to us by x to the fourth plus 2x squared. And then we're asked to find the derivative. So we're asked to differentiate g of x to the third power, which is essentially the same thing as saying what is d dx of x to the fourth plus 2x squared to the third power. Now, what we're going to do is we're going to use the chain rule, okay, this power chain rule that we've been given. So what we do is we pretend like this inside is a single variable. In fact, really what's going on here is we're saying, yeah, okay, let's go ahead and let's let g of x, let's just call it, I don't know, u. And so what we're asking for is what is d dx of u to the third. Okay, that's what we're really asking. But now here's the thing that's important about notation. This x right here and this u right here are not the same. So I need to make a substitution. I need to say, okay, I got d dx, and I need to change that into d du. So I need d dx to become d du. Well, how we do that is the easiest way to remember is with this Leibniz notation, is to go ahead and say, well, you know what? What if we just write d dx as du dx times d du. Now, it doesn't really work quite like this, but what we can do is we can think about, well, what if you cancel these guys out? Then you just be left with d dx. So again, it doesn't really work like that, but it's nice to remember it that way. So what this guy right here becomes is this. We've got d du of u to the third, but to convert d dx into du, we have this because this is equal to d dx. Okay? Remember, cancel these guys out, it looks just like this. This is an easy way to remember it. So I have my du in here, I just need my du dx. So if these guys crossed out, you'd be left with d dx. Like that. Again, it doesn't work like that. I mean, it does computationally. It works like that, but mathematically, we get, this isn't necessarily the best way of. It doesn't actually cancel out because they're not ratios. Okay, but this right here is 3u squared, and now du dx. Well, u was equal to this. So what is du dx is the derivative of this guy. So that's going to be 4x to the third plus 4x. And u, we said, was equal to this. So we can go ahead and stick that guy in here. So that's 3 times x to the fourth plus 2x squared times 4x to the third plus 4x. This is your overall answer. Now, I want to point this out. I went through a lot of hoops to get to here, but here's how everyone does it in practice. They take this guy, they bring it out front, subtract 1 off the power, and I forgot to do that because this right here was squared. I forgot to write that guy in there. So bring this guy out, leave that guy, raise it to the power. So you pretend like this is your variable that you're differentiating with respect to, and then you just remember that at the back end, you need the derivative of this inside piece right here. And that's all you got to really do, okay? So pretty straightforward. Just go ahead and pop this guy up front, leave the inside, subtract the power, but then multiply it by the derivative of the inside. Now, real quick, you can go ahead and multiply all this mess out, but most people don't. They just leave it just like this.